Jai Hind viewers, welcome to AKGEC Digital School. My name is Pankaj Singh from IT department. Today I am here to record a video lecture of subject Computer Organization and Architecture. We are here to discuss a Unit 3 topic, that is pipelining. So now we have some outlines regarding it. These are the outlines. What we discuss here, these are what is pipelining. Secondly, type of pipelining. Third, space time diagram, and fourth one is explain their example along with some real values that will help to understand how exactly pipelining will work. So before going to the pipelining, we discuss why we need pipelining. Okay, so pipelining basically help in to achieve the parallelism within a machine. So first we know what is parallelism. So in a machine, parallel processing is achieved by three methods. First one is pipelining processing. Second one is vector processing. And third one is array processing. So today we discuss here only pipelining processing that will help to achieve the parallelism within a machine without changing its real parameters, like without changing in its hardware or software. So how it is achieved, that is discussed in a pipelining. So before going to detail, we first take the definition of pipelining. So what is pipelining? We have a definition here. Pipelining is a technique of decomposing a sequential process into a sub-operations with each sub-process begin execute in a special dedicated segment that operate concurrently with all other segments. What we do in pipelining exactly? In sequential processing, we execute instruction in series. Okay, like first I1, then I2, then I3, and so on. But what we do in pipelining? Pipelining, we divide a instruction into a sub part, or we can say segments, that help to execute a instruction efficiently and accurately with a fast processing. How it is do? We understand it in a example that I discuss later. So we now take the second point of pipelining, because before going to the example, we should know exactly the meaning and implementation of pipelining. Pipelining can be visualized as a collection of processing segments through which binary information flow. Third point, each segment perform partially processing dedicated by which the task is partitioned. In serial processing, a whole instruction is executed once, but in pipelining, an instruction divide into a subparts and execute in a partially processing manner, or we can say in a subpart. We understand it in detail when we go for an example. Now the final result is obtained after the data has passed through all segments. So first we know how to divide the instruction into segments, and the result of this segment is stored in a different registers as per requirement of a instruction. Now after that we will discuss type of pipelining. So before going to that, we understand overlapping of pipelining is achieved here. The overlapping of computation is made possible by associating a register with each segment in a pipeline. As I said earlier, in pipelining we use different registers after each segment. For example, we divide an instruction into a 4 segment, then we place here it's segment 1, segment 2, segment 3, segment 4, After that, we will also place registers that store the result of concerned segment R2. Similarly, we have here R3, and then we achieve the final result after going through the register 4. It is a general description of an instruction, how it is divided into a segment and result in a different registers as seen in a diagram. As I said earlier, the register provide isolation between each segment as we seen in a diagram. We have here registers that isolate two segments in between, that work as an isolator between. When segment 1 is processed, its result stored in a register R1. Likewise, when segment 2 is processed, its result stored in a register R2, and so on. Here we know the type of pipelining. Pipelining is of two types. First one is arithmetic pipelining and second one is instruction pipelining. Here we will discuss example on both pipelining, how the mathematical expression is divided into number of segment, and this segment is processed by the help of different registers, or we can say variables we use for our instruction. Secondly, in an instruction pipelining, as we all know that these are the prerequisites of pipelining, we should know the instruction process, in which we know how instruction is executed in different part. Like instruction consists generally 4 parts: instruction fetch, address fetch, instruction execute, and write result. These are the basic division of an instruction. In an instruction cycle, we use 4 steps. What is arithmetic pipelining? Arithmetic pipelining basically is used for enhance the speed of the existing arithmetic operations that generally execute ALU. What type of arithmetic operations? Like floating point operations, multiplication, fixed point numbers, similar mathematically computation encountered in a scientific problems. It also helps to execute floating point operations easily. That also used to add or floating operations that are required in a mathematical expression. And we also take an example like A and B are two fractional that are represented in a mantissa. Here we have A and B. So such type of operations is easily and accurately executed by using arithmetic pipelining. Here is one question: is it execute sequential pipelining? Yes, but that enhance the speed by breaking the instruction into a subpart, or we can say like we store A in a register R1 and the whole expression in a R2, and as we go for example, we see how this will help to execute a instruction in a subpart. Here we have a instruction pipelining. In instruction pipelining, we divide a instruction into a segments, or we can say subparts. Like instruction we read from the memory. While we reading a instruction from memory, the previous instruction will execute into a other segment. That will make a cascade form. Like first we execute the first instruction, fetch the instruction, second one will execute, third one will fetch the operand, and fourth one will write the result. For it we will take a detailed example in which we understand how it is exactly work. Here the step of instruction pipelining, in which first we fetch the instruction from memory, as I said earlier, because for execution instruction we know the address of the memory, we fetch it from the memory. Second, we decode its type. As I discussed in the last video lecture, we understand the type of instruction, it is of three type: memory, reference instruction, IO reference instruction, and third one is register reference instruction. Okay, we have a instruction that contain address, along with we have a 3-bit MSB that will help to identify the type of instruction, in which it is divided into 0 and 1. 0 represent memory instruction and 1 represent register. After that, it is subdivided into other parts, like the register instruction is of 110 till 110, and if we have 3 ones, that represent memory instruction. It is a part of instruction cycle. If you want to go to in detail, go through the flow chart of a instruction cycle, in which how we decode a instruction, you go through it. Then we will calculate the effective address of a instruction. After that, fetch the operand, the type of operation which perform on a data we fetch from a memory location. After that, execute the instruction, and as I said earlier, finally we store the result of a executed instruction back to the main memory. These are the basic steps, or we can say the classification of a instruction pipeline into a sub step. First, instruction fetch, instruction decode, calculate effective address, fetch operand, execute instruction, and store result. These are 6 steps an instruction contain during the execution process. Now, we have an example of arithmetic pipelining. What is arithmetic pipelining? As I said earlier, the operation that execute within a ALU, especially regarding to the calculation, either it is addition, multiplication, subtraction, like that. These operations is solved by the help of arithmetic pipelining. So, how it is executed and how it's work, we will understand with the given example. Here we have an example in which we have an expression, or we can say equation, that consists A dot B plus C. So, how it is execute? By the help of a processor without changing its parameters, or we can say without changing its hardware configuration to enhance its speed. It is done here by the help of given example. We will understand it here. As we see over the screen, we have 3 variables A, B, C, and up to what level we will execute it. The number of execution, it's 1 to 7. So, this equation will execute 7 times for the same. So, how it will done? As we see here, the first variable is stored in a register R1. As I said earlier, after each segment, we have a register that store or holds the result of a specific segment. Likewise, the result of A dot B and the B is stored in a register R2, and the result of R1 and R2 in a form of multiplication is stored in a R3. After that, we will perform addition. We store the result of C in register R4. As we know that within a machine, all content or information initially stored in a register. So, we place these information into a registers. So, it's basic, we know that we use board mass to store or copy the result. So there may be a question why we store first A and B, because it's a combination of multiplication, and as we read from left to right, it has highest priority. That's why we first store A and B. Likewise, we will go for any expression using BODMAS rule. Then the final result will store into a register R5. Register R5 will contain R3. What is R3? That is A dot B. And what is R4? That is C. So here question, how many times it will repeat? The value of I will be 7. That's also given in question. It may be I is equal to 5 or I is equal to 20. So we will make a table. Before going to a table, we make here a diagram that will help out how these operations will execute. As we see in a figure, we see here AI that is stored in R1, similarly BI that is stored in a R2 is multiplied here, and the result of multiplication goes to register R3, and the result of R3 along with parallel addition of R4 is added here, and the final result go into R5. So it is a one step. So how other step will execute for I is equal to 7. So here it's a breakup along with segment. As we see here, it is known as segment 1, right, in which we input two variables A and B. What is segment 2? Segment 2, at level 2, we have input of register R3 and register R4 as we seen in a table. What is segment 3? We have R5 in a form of final result. So we divide our equation in such a way that we can easily understand the segment at a same level. If we see here only segment 1, we have only 2 registers. Likewise, we have segment 2, we have 2 register R3, R4, and similarly we have segment 3, we have register only R5. Then how it will work, or in a table form how it will be calculated? As we see here, we put into a segment form in a horizontal way segment 1, segment 2 and segment 3. What will happen in a first clock pulse? We consider a unit time for a execution of single step. Likewise, we have a 1 unit time. So 1 represent here. At a 1 unit time, there will be a first input of R1 will be A1 and the input of R2 will be B1. Similarly, the other step in a ideal condition, because they have no input from the previous stage, so they mark as a dash or blank. But at a time of 2, these inputs is processed by the help of multiplier and go to the R3. As we see here, what it will be, the next part is transferred to the first part transferred to the next segment, and the next input will be taken here as a A2 and B2. So we represent it here. At same level, we have C1, and the R5 is in a ideal condition, that will mark as a blank. At a time, at a third input, or we can say I is equal to 3, we have A3, B3 as an input, and the next stage segment 2 process A2, B2, and what will here in a segment 3, there A1, B1 plus C1. As we see here in a segment 3, at unit time 3, the first instruction will execute, or we can say the first complete equation will execute. But up to what level we have to execute? That is I is equal to 7. When we go to 4, similarly as the previous stage, when we have A4, B4, segment 2 process A3, B3, and segment 3 process A2, B2. Hopefully you understand the connection between the value of these, and up to what level we have to calculate, that is I is equal to 7. So when we have A is equal to 7 and B is equal to 7, we will get here A6, B6 as in the previous stage. Likewise, so what is the purpose of to calculate these things? If we calculate by using arithmetic pipelining, it will execute in 9 unit time. How much instruction? Much equation or instruction? These are 7. What will do? What will happen if it is executed by the help of serial or sequential method? It will take 7 into 3. What is 3? Number of segment. That will take 21 unit time. But in this method, it will execute only in 9 unit time. That is the advantage of pipelining. Pipelining enhance speed and the throughput of a machine without editing or changing its hardware and software configuration. So hopefully you understand the basic difference between the execution of parallel pipelining and sequential processing. In sequential processing, the same task is executed in 21 unit time, but here we execute the same equation or instruction in 9 unit time, because we have to need a time to complete execution of instruction. As we see at a unit time 9, there is only execution of A7, B7 and C7. So the complete instruction will execute like this manner in a arithmetic pipelining. So any expression, first we break it into a segment, and segment will contain a number of registers. It's on request or demand of the equation. Now move to the, hopefully you understand this topic. Likewise, we have another example of, as we have a example of, as I discussed earlier, we have a segment. What is segment? Segment consists the specific operations just like into a previous. These are the segment. What operation here perform? These are multiplication, input C, and after that addition. So this result is stored in a registers. So we have take here example of 4 segments along their registers. It's an ideal diagram. The number of register segment may vary as according to the equation we get from mathematically. After that, we will calculate here the space time diagram. What is space time diagram? That will help to identify how much time my equation will take or how much time a instruction will take to execute in a pipelining manner. Here we take the same example. It represent number of segment and it represent unit time, or we can say clock cycles. For example, if a segment take 6 unit time to execute, so how much time, because a complete instruction here break into a segments. So one instruction will take 6 unit time to execute in a one segment. So how much time it will take to execute the whole instruction? So that will be a, here we understand with example, when the instruction during the segment 1 we execute during T1, during T2, the second part of segment will upload, or we can say fetch here. Likewise, when we operate T3, we will fetch the second part of segment 2, and likewise the segment 3, likewise segment T1. So from the given figure, we identify it will take 9 unit time to execute 4 segments. But if it is in a sequential manner and each segment have a required 6 unit time, that will execute in 6 into 4, that means 24 unit time. Means all these segments will execute after the complete execution of the first segment. Like the first segment will over here, the second segment will execute after this one, third one after this one, and fourth one after this one. So that will take complete 24 unit time. So hopefully you understand the advantage of pipelining. Pipelining execute the same segment in a 24 unit time. So sorry, in a sequential it will execute into 24 unit time, but in parallel processing it will execute in 9 unit time. Now we will take some formula that are required during the execution of such calculation, like time space diagram and other parameters. Here we have some formula relevant to space time diagram. Now consider the case where K segment pipeline. What is K? What is TP? What is n-1 TP? Here we take example, or we represent segment by K, right? And number of stages by n. Okay, n means the time required. Right? So calculate the time of a instruction, or we can say space time diagram. If we have, we will write down the formula here. K plus n-1 time required. We have formula K plus n-1. Here K is segment, n time required to execute a segment. So let K is equal to 10, and each segment have 4 stages. So how much time it required? So it is very simple to calculate. Here put the value of K 10, like, and n here 4 minus 1. So 10 plus 3, that is 13 unit time we required to execute a instruction. But what will happen if we execute in a sequential method? That will take 10 into 4, that is 40 unit time. That is the advantage of pipelining. The same thing we discuss here in term of, as I said earlier, in a instruction pipeline, instruction is divided into 6 parts: instruction fetch, instruction decode, calculate effective address, fetch the operand, execute the instruction, and store the result. The same thing is put into a space time diagram in a form of execution. We here take the broad part of a instruction. These are required, like fetch instruction, decode, address, fetch, operand and execute instruction. As we have here instructions, and these are the time required to execute these instruction. So if an instruction is divided into a 4 stages or 4 part, the first instruction will take this. After that, the second one is uploaded. When the first instruction is decode, the second one is fetch. When the first one is fetch, second one is decode, and third one is fetch. Likewise, when first one is execute, second one is upload, or we can say fetch operand. After that, decode and fetch the fourth one. Likewise, if we will go to this, we will find out the number of time required to execute 7 instruction. That means we need only 13 unit time to execute these instructions. So it is an advantage of pipelining. So pipelining help to execute an instruction into a sub part in 2 manners. First one is arithmetic and second one is instruction pipeline. So hopefully you understand this topic. We will come with the next topic in a next slide. Thank you.